This is question 22 on the higher calculator paper. Okay, let's read the question first. It said a frostrum is made by removing a small cone from a similar large cone. So there are a couple of key words here. The word similar is really important because that tells you that the shapes are similar and they're in proportion to each other. And we're going to need to use that in a bit. It also tells us that this bit here, this frostrum, is a cone that you've chopped a bit off and you've removed. And this bit with the dotted line is the bit that's been removed. The height of the small cone is 20 centimeters. So the height of the small cone is 20 centimeters and the height of the large cone is 40 centimeters. The diameter of the base of the large cone, so the diameter of the base of the large cone is 30 centimeters. All that information is on the diagram. Okay, you could see it all there. The question wants you to work out the volume of the frostrum, give your answer correct to 3 significant figures. So again, another part of a question where it says give your answer correct to 3 significant figures or a certain number of significant figures. Alright, now in this type of question, you need to know how to work out the volume of a cone. And again, we're going to go back to the formula sheet. Right, the formula sheet at the front of the exam, we looked at several things already. We looked at the cross-section and the area for trapezium, but the volume of a cone is over here. It's written down here. Right, there's a cone, and the volume of a cone is 1/3 pi r squared times the height. So you've got the height of the cone, r squared is the radius of the base, right? So that's the volume of a cone. Now I'm going to look, if I was in the exam, I'd look for that, and then I'd make a note of it on my page. So the volume is going to be 1/3 pi times radius squared times the height. So for this particular question, they want us to work out the volume of this bit here at the bottom. In order to do that, I'm going to work out the volume of the large cone, right? So if this bit that was removed was still on there, what would be the volume of the whole thing? Then I'm going to work out the volume of the smaller cone, right, and take away one from the other. So just for using the space and making sure I show everything, I'm going to put volume of large cone is equal to, now I need, so for the large cone, I need to know what the radius of the base is, and I need to know what the height is. So the height of the large cone is 40, and the base of the cone, its diameter is 30, so the radius of it is going to be 15. Now I'm going to use the formula 1/3 times pi times radius squared, so that means 15 squared, and then times it by the height, which is 40. And now I need to just use my calculator to work all of that out. Now 1/3 is 1 divided by 3, so I'm going to work out that to begin with. I'm going to times that by pi, so remember shift and then the pi button down at the bottom, times 15 squared times 40. So I've actually put everything in there and press equals, and there's my result, 9,424.777. 9,424.77. I'll just round it up there, 8. Okay, so that's the volume of the larger cone. Now working out the, I'll put the units in, centimeters cubed because it's volume. Now working out the volume of the smaller cone, so put an arrow over there. So for the small cone, what is its what's its height? So the height of the small cone, I could see from the question, they told me that that was going to be 20 centimeters. This bit here, the diameter of the small cone, or the base of the small cone, they haven't given that to me, but I need to work this out. Now because these two shapes are proportional or similar, if I halve 40, I get 20. If I halve 30, that tells me that this distance here, the diameter of the base of the small cone, is going to be 15 centimeters. So what does that tell me about the radius? The radius of the base is going to be half of that, and that's going to be 7.5 centimeters. Now that's really important. And it's really important that you understand that as well. So I'm going to do the same thing, work out the volume of the small cone, and I'm going to use the same technique that I did before. 1/3 times pi times radius squared, which is 7.5 squared, and then times that by its height, which is 20. And then we go on to work that out in the same way on the calculator. So 1/3 is 1 divided by 3. I'm just going to work that out. Times that by pi, so press shift and then the pi button down at the bottom, times 7.5 squared times 20. Press equals, and that's going to be 1,178, and a bit more in the decimals part, 1,178.097. Okay, centimeters cubed. So we've gotten almost to the point of answering this. So that for the frustum, the volume of the frustum is going to be the volume of the big cone, 9,424.778, minus the volume of the small cone, which is 1,178.097. I'm going to put that into the calculator to work it out. 9,044.778. Take away 1,178.097 equals 8246.681. Now if I just move this up a bit so that we have enough room for the last part of this. The question says, give your answer correct to 3 significant figures. So the volume of the frustum is going to be this number written to 3 significant figures. Now remember, when you're doing significant figures, you count from the front. 1, 2, 3, and then you're going to chop it off there. So that's going to be 8,200 and, well, do I need to put 40 or do I need to round that? Well, because this next number along is 5 or more, that answer is going to be 8,250 centimeters cubed. And that's what I'd write in the answer space. There are 4 marks for this, which is not a lot, right, for the quantity of work. However, you're going to get the formula for this from the formula sheet at the front. You just need to put the numbers in, and then the other challenge is really to make sure you figure out the diameter of the base and then work systematically through it. If you take your time, you should be able to get full marks in this, and especially for those people aiming for the A's and A stars, you need to make sure you get this all right.